Hello, my name is Michael. Welcome to my YouTube channel. This video is a continuation from a previous one I did, which is focused on inter-AS MPLS VPN. The last video I made was the option B using the next up self method. Today, I will be focusing more on the option B using the Redistribute-Connected method. The agenda for today's video is a recap of the previous topic, which was inter-AS MPLS VPN option B using next up self method. And then I will take you through the case study for today's video, which is also based on inter-AS MPLS VPN option B using Redistribute-Connected method with route target rewrite option. After which I will show you a configuration section where the ASBRs will be configured, and then I will make a conclusion with respect to what I've discussed on these topics. Please note that the designs, the topologies, IP addresses, and configuration used in this illustration are not reflections of a real live entity or any infrastructure. They are basically imaginary or fictitious. Now to the recap. There are three types of methods that you can adopt when deploying the inter-AS MPLS VPN option B, and they are next up self, Redistribute-Connected, and EBGP multi-op. In some cases, you will find this to be multi-op option. When using the next up self method, you are basically configuring the ASBRs of your local ISP to rewrite the next up address of prefixes that are received from the remote ASBR. And note, you have to disable the automatic route filtering feature on the ASBR in order to allow multiple VRF entries on the table of the MP-BGP on each of the ASBRs. In cases where you are using a route reflector, you also have to disable this in that case. And sometimes you may not have to if you are rewriting route target on the ASBR. Today, I'm discussing mainly on the Redistribute-Connected method of inter-AS MPLS VPN option B. In this case, you do not need to rewrite the next up address on the ASBR for all the routes that are received from a remote ASBR. Which means when router 1, in this case, receives prefixes that are coming from router 12 from R10, router 1 does not need to rewrite the next up address to become its own self IP when it is advertising it to the route reflector in this case. You recall in the previous video that I made, we had to specify in the configuration that R1 and R4 should rewrite the next up address to their own local address. In other words, we configured the next up self when pairing with the route reflector. However, in this case, we do not need to consider that as an option or an action to be taken. We simply just leave that as is and we redistribute connected into the local IGP. And that is what is shown here. In this case, we do not specify next up self like I said before. We only simply pick this local inter-AS link on the R1 and redistribute it into OSPF, being the internal gateway protocol on this ISP1. The same thing is done on R4 that is Redistribute-Connected, which is targeting only this interface that is going to R9, and redistribute it into the OSPF that is running. Similarly, we'll have to redistribute the inter-AS link into ISIS in this case. Similar to the R10 config as well, we have to do same in order to have the BGP next hop reachability requirement fulfilled. And now to the configuration. I will take you through the configuration on the Asbr basically. These are the current assumptions that you need to consider while going through the configuration section. All IGP sessions have been converged in each of those ISPs. That is, all the routers in each of these ISPs are able to reach one another. Similarly on this as well, R9, R11 and R10 are able to reach one another. R11 also is able to reach R12 because that is part of the assumptions in this case. And like you see in this assumption, multi-protocol IBGP has been configured on all internal routers of each of the service provider. There are no special configuration existing on any of the routers in the network, and all VRFs also have been configured on the PEs. This is a table that is showing us the VRF and VPN information on each of those networks. That is the part of the enterprise as its configurations, and the ISP as well with the configurations below in the table. Very quickly, I will show you how to configure each of these steps on the Asbrs. First, you need to disable the automatic route filtering feature on the Asbr in the route process for BGP. You also need to configure the multi-protocol eBGP between the Asbrs. In this case, there is no need to enable LDP or any form of IGP or VRF on the inter-AS links that is connecting the Asbrs of each of those ISPs. In my previous video, I mentioned the need to consider route target rewrite, which is optional, but rewriting the route target on the Asbr reduces the configuration that you need to do on the PE or the route reflector. In this case, once we have the route target rewritten on the Asbr, we do not need to disable the automatic route filtering feature on the route reflector, simply because the Asbr would have stripped off the remote route target that is received for all the prefixes in case those route targets are not matching the local targets that we have on this service provider. This Asbr will rewrite what it received with what it has locally, so that the route reflector and the PE would not need to do any form of importation of a remote route target. It simply will receive that and just put it directly in its table. That's the VRF table that is matching that route target that we have rewritten into. Then we need to redistribute connected inter-AS link into the local IGP on the local AS. In other words, this means on R1 we have to redistribute this inter-AS link into OSPF. Similar action needs to be taken on R4, and as well we have to do same on R9, which in this case we have to redistribute this inter-AS link into ISIS and replicate same on R10. After this had been done, we will do a verification of reachability between R12 and R13 and R14. Remember, this is a campus site of an enterprise network, while this is a remote site. And so the reachability will simulate a service provision between the campus and the remote. Note, there is no need to rewrite next hop address on the received prefixes from the remote AS. Like I've said earlier, there will be no need for you to specify next hop self when peering between R1 and the route reflector and also on R4 with the route reflector, simply because we have fulfilled the reachability of the next hop by redistributing this connected into the local IGP. On the PE, you only need to worry about pairing the PE with the CE using the adopted PECE route protocol or routing protocol, which could be a static route, it could be any of the IGPs, or depending on what the design looks like. In the case where you do not have the route reflector deployed, let's say R2 is not in this case a route reflector, then this PE, which is R3 and R4, will have to pair with every other router that has to participate in the routing. However, in a case where you have a route reflector like this, you only need to pair the PE with the route reflector on multi-protocol IBGP so that we can have a replication of those routes properly. Remember, as mentioned in the assumptions, this configuration of the pairing between the PE and the route reflector have been done, and so we will not focus on that part in this video. The next section will be the configuration of the Asbr, so please don't go away. For the configuration section, please check the link in the description box. Thank you.